Hey there, EduVos students. I'm absolutely thrilled to have you here for this explainer. Today, we're tackling the final, and honestly, probably the most impactful section of Chapter 15 in our software engineering journey. I want to start us off with a hook, a real fundamental question. Why spend months, or literally even years, building a new program from scratch when you can just buy the whole thing? In the modern corporate world, this is a question you're going to face constantly. So today, we're looking at the absolute highest level of software reuse. Let's dive right in.
Here's our roadmap for today's session. First, the power of system reuse. Then, configuring ERP systems, followed by integrated application systems. After that, we'll look at the 4 integration nightmares, do a Chapter 15 master recap, and wrap up with our final exam focus.
All right, let's start with Section 1, the power of system reuse. As always, we need to define our terms before we explain them. Application system reuse is also known as COTS. That stands for Commercial Off-the-Shelf Systems. What this means is you're taking an existing software product built for the general market and adapting it to meet a specific customer's needs. And here's the absolutely crucial point to lock in for your exams. You do this without changing the source code. You're not going in and rewriting the core programming. The vendor controls that code. Instead, you're just using built-in configuration mechanisms to tailor the software's behavior to your organization. Moving on to Section 2, let's talk about configuring ERP systems. So what exactly is an enterprise resource planning system or an ERP? Well, these are massive, generic systems produced by industry giants. Think SAP or Oracle. An ERP contains various modules for all sorts of different business functions: purchasing, human resources, inventory, supply chain management, you name it. But what makes an ERP so incredibly powerful is that all these separate modules are linked together by a common database and a shared set of business rules. This means information just flows seamlessly right across the entire enterprise. But here's the core problem, and it's a major misconception I want to clear up for you right now. Configuring an ERP is not like just going into your phone and tweaking the display settings. It is incredibly complex. In fact, configuring an ERP often forces a company to change its entire business process to match the software's underlying assumptions. The software basically embeds the vendor's idea of exactly how a business should run. If your organization does things differently, well, you often have to change your organization's behavior to fit the software, not the other way around. And this perfectly illustrates the friction this can cause. Let's look at an example straight out of your textbook. Imagine a university buys a massive ERP system to manage its operations. Now, the ERP was originally built for the corporate world, right? So a fundamental assumption baked into its code is this concept of a customer buying a product. But a university's reality is completely different. A university has students taking courses, and it manages research grants from funding agencies. A student is definitely not simply a customer buying a product. So the built-in assumption completely breaks down. In the textbook's example, it literally took months to resolve this mismatch, and even then, the system only partially met the university's requirements. It just goes to show why customizing these generic models is so fraught with risk. Okay, Section 3, Integrated Application Systems. Often, engineers find themselves needing to build a new system by combining multiple existing applications together. We actually call the code that holds all this together glueware, which is pretty fitting. Imagine a company that has a very old legacy ordering system. They really don't want to replace it, but they need to connect it to a brand new e-commerce web platform and a modern email server. Now, these systems were never designed to talk to each other. They're totally incompatible. So how in the world do we integrate them? We use an adapter. You'll definitely want to write this definition down. An adapter is a piece of code written specifically to translate data formats and representations between incompatible application systems. Think of it like a highly skilled translator at the United Nations. One system speaks French, another speaks Japanese. The adapter sits right between them, receives a message, translates the format, and passes it along so the next system can actually understand it. To understand how this works in practice, let's consider an integrated procurement system. Picture a client setup with a web browser and an email system. Below that, on the server side, you've got a web service that needs to interact with an older ordering and invoicing system. Now, think about where the adapters need to be placed. You'd have an adapter sitting squarely between the web service and the ordering system. You need another one between the ordering system and the email system. These systems cannot communicate directly. They absolutely rely on these adapters acting as translators so the data can flow successfully across the whole setup. Which brings us to Section 4, the 4 integration nightmares.
Two researchers, Bohm and Apts, identified 4 major integration nightmares, and these are risks you absolutely must memorize. First up, lack of control over functionality. If the off-the-shelf system has a bug or just performs poorly, you can't just go in and fix the source code. You're stuck waiting for the vendor. Second, interoperability problems. Even when you're using adapters, systems often have conflicting assumptions about things like event handling, making them incredibly hard to actually sync up. Third, no control over system evolution. The vendor might force an update on their system that completely breaks your custom adapters, which can crash your entire integrated platform. And finally, poor vendor support. If a problem arises, the vendor might not even care about your specific integration issues, leaving you totally stranded. All right, let's zoom out for Section 5, our Chapter 15 Master Recap.
Let's quickly weigh the general benefits against the problems of software reuse. On the plus side, reuse gives you accelerated development. It lowers your risks because the code is already tested, and it allows for the really effective use of specialists. But on the downside, you're going to face the not invented here syndrome, where developers resist using code they didn't write themselves. You also have to deal with the sheer cost of finding, understanding, and maintaining a massive library of reusable components over time.
Moving a bit further up the scale of reuse, we have application frameworks. Remember this definition for sure. A framework is a collection of abstract and concrete classes that are adapted and extended to create an application system. They usually incorporate really good design practice through design patterns, which basically gives developers a solid, reusable foundation to build upon. Next up, we discussed software product lines. This is where an application type is generalized around a common core architecture. Basically, the vendor has a base application and they customize and configure it to create related applications for specific different clients. It's kind of like a car manufacturer using the exact same base chassis to build a sedan, a hatchback, and an SUV. And finally, we arrive back at today's main topic, application system reuse. This is the ultimate, largest scale of reuse. Instead of just reusing classes or a base architecture, you are reusing large-scale, complete, off-the-shelf systems, like those massive ERPs or integrated COTS systems we talked about earlier. You don't write new core code, you just configure the system to meet the organization's specific needs. And that leads us to our last stop, Section 6, Final Exam Focus. If you want to absolutely ace the Chapter 15 section of your test, you've got to be able to confidently answer these 3 questions. 1. Can you define an ERP and explain how its modules share a common database? 2. Can you explain an adapter's vital purpose as a translator between incompatible data formats? And 3. Can you articulate the downsides of relying on COTS systems, specifically listing out those 4 integration risks identified by Bohm and Apps? If you can answer these clearly, you are going to be in excellent shape. Let's wrap this all up. Your final takeaways are to memorize those key definitions and make sure you can thoroughly articulate the integration risks we just went over. Always remember that while configuring large, off-the-shelf systems can definitely be frustrating, and yeah, it forces you to adapt your business behavior, it is an absolutely essential skill in modern corporate IT. It's just often so much faster and cheaper than writing custom code. And that concludes our mastery of Chapter 15. In our next explainer, we'll be teasing apart Chapter 16, where we dive into component-based software engineering. Until then, keep studying hard, focus on those core definitions, and before you go, consider this. If building a program from scratch is too slow, and buying off the shelf forces you to change your entire business, is true software independence even possible anymore? Something to think about. Catch you in the next one.